All right. Now we'll talk about the directional static stability. Directional static stability. Okay. So if you talk about directional static stabilities, in directional stability, what we are going to study, we have a yawing moment. Yawing moment. And this yawing moment is what about always about z axis. This z axis also called as vertical axis. Vertical axis. So always remember your yawing moment will be always about vertical axis. And what are the control surfaces here? The control surface is basically rudder. A control surface. In short, no? And this is the one thing. Now, just like in case of the uh, pitching moment, we had angle, that was angle of attack, nose up, nose down. Then we had seen that lateral static stability. So there was rolling, and that rolling we had taken angle, that was the banking angle phi, which was from the vertical axis, and we had taken side slip angle, that too also had taken from the horizontal axis. So now because this is the yawing moment, so we have to take yawing angle. Okay, we have to take yawing angle right now. So what will be the conditions? What is the sign convention here we are going to talk? So sign convention is nothing but for the directional static stability. Sign convention. So sign convention you need to remember here. Okay, yawing angle, yawing angle, which is denoted by psi now. Okay, yawing angle towards the starboard, towards the starboard, towards the starboard. Okay, starboard in the sense right wing, is towards the starboard. Starboard in the sense right wing is taken positive. This is the sign convention. Okay, for the yawing moment towards the starboard is taken positive, and also also yawing moment towards also yawing moment towards the starboard, towards the starboard is taken positive. Number one, this is the sign convention. Number two, since psi, which is nothing but yawing angle, is equal to minus beta, psi or beta, any of any of two any of two can be used, any of the two can be used to represent to represent the criteria of directional stability. Directional stability. Okay. So basically, yawing moment, if you are see how you would get that uh, yawing moment. I mean, which like for the pitching moment, side view we had seen for the airplane. So the proper angle of attack you can see once you see the side view. Okay, for the pitching moment. For the rolling moment, front view if you draw, then you will get the rolling moment properly, and the banking angle you can see. Okay, even though side slip angle you can see, right? And for the directional or for the yawing moment, for the directional stability, you have to see draw the top view of the airplane, so you will able to see the that yawing angle. Okay, yawing angle, or you may able to see the uh, exact deflection of rudder, and like it is which towards which wing it is moving, that you will able to see once you draw the top view of the airplane, once you draw the top view of the airplane. Okay, so yawing moment. So directional stability of an airplane is its natural or inbuilt ability to recover from a disturbance in the yawing plane about the normal axis. Okay, about the normal axis. So if the aircraft is what got disturbance because of the gust or because of the turbulence and all, then the it will have a yawing moment about the vertical axis because of the disturbance. Okay, once disturbance gone, then the airplane will try to come back to its original position. Once the plane is what able to come back to its original position, then you have to say that aircraft is what directionally stable. The aircraft is what directionally stable without any pilot input. That is the simple basic idea already I have discussed in the starting only. So if it is coming back to its original position, then you will see yes, that airplane is what directionally it is stable, right? Number one. Number two, if you want to go for the go to check the directional stability, then as I told you, we have to draw the top view of the plane. If you draw the top view of the plane, then you will able to see the moment about vertical axis. Now see, I'll show you. Suppose, all right, so we are having a top view here, right? And the airplane is what? The top view of the, like this. Okay, suppose about the vertical axis. Now, once the disturbance came and it is going to hit to the aircraft, then this aircraft will have a moment in the sense, one wing, suppose this wing got more lift. I must draw in this way, more lift, and this wing is now less lift. So obviously if it is having a more lift, or in terms of drag also you can consider, like this will have a, you can say, here the drag is what more and here drag is what less. Then what will try to do, this plane, plane will try to, this plane will try to
To move left.
rotate in this direction. Yes or no? Yes or no? You can say,
हाँ सर.
uh, here we have a more drag and here we have a less. Okay, so this plane will try to yaw about this vertical axis, just perpendicular to this dot, perpendicular to this dot. So this is nothing but right wing, right, which is nothing but starboard, and this wing is nothing but left wing, which is also called port wing, right, port wing. So once this airplane is what yawing in this direction, so if the airplane itself coming back after disturbance, it is coming back to its original position. So this is the restoring moment basically. If then the aircraft is what trying to come back to its original position again, so restoring moment suppose it is getting, so you have to say it is laterally stable. This is the uh, restoring moment. Restoring moment. All right. So this will be the laterally stable, directionally, sorry, directionally stable airplane. Directionally stable airplane. This will be called a directionally stable airplane because it is trying to come back to its original position. Okay. Now, so what are the criteria for this? What are the criteria for this? So when an airplane is what yawed, it returns in unbalanced yawing moment, and that yawing moment we are going to take n. Okay, n is nothing but yawing moment. Yawing moment here. Okay, this one, this is nothing but yawing moment. Yawing moment. So yawing moment, and once restoring moment will balance this yawing moment, and again it will get its original position. So that time you have to say it is directionally stable. Number one. Number two, that yawing moment is what denoted by n. Okay, now we have to, based on this we have to take, okay, n is the yawing moment and psi is the yawing angle, or also psi is nothing but minus beta, which is side slip angle. Okay, anyway, we have to take the three criteria. Case 1 criteria. Case 1. Case 1. If the yawing moment tends to restore the airplane back to its original condition of 0, yeah, then airplane is what is statically directional stable. Then it is nothing but dn by d psi, which is less than 0, or it is also dn, because for psi and beta both are just opposite. So you can say dn by d psi less than 0, or you can say dn by d beta greater than 0. Both are the same thing, and this is for directionally stable. Directionally stable airplane. Okay, case 1. Similarly, case 2. What is case 2? Case 2 is nothing but dn by d psi uh, greater than 0, or you can write equal to 0. Equal to 0, or the same thing you can say dn by d beta is equal to 0. It is neutral, directionally neutral. Neutral. And case 3. Case 3. What is the case 3? Case 3 is nothing but dn by d psi greater than 0, or dn by d beta is less than 0, directionally unstable. Directionally unstable. This also, as I told you, n is the yawing moment, but what is the cn? It's a yawing moment coefficient. Just like a cm was the pitching moment coefficient, m was the pitching moment. So everywhere you had written dou cm cg by dou alpha less than 0. That was the criteria for the longitudinal uh, uh, stability. Okay. So for the directional stability, we had written in terms of uh, that yawing moment. Otherwise, also you can write dou cn by dou psi, or dou cn by dou beta. Okay, meaning is same. Similarly, dou cn by dou psi, or dou cn by dou beta, or dou cn by dou psi, or this is for stable plane, this is for neutral plane, and this is for unstable plane, airplane or plane. So in exam directly they are asking, okay, one more thing, this uh, in short, always remember, like for pitching moment, for longitudinal stability, lateral stability, and directional stability, right? We have all three. Now if you check dou m by dou alpha less than 0 is stable. For stable criteria I'm writing this. Also you can write dou cm, about which, about cg. So dou cm cg by dou alpha less than 0, this was stable, you said. For stable only I'm writing. Similarly, for the lateral stability, what was the lateral stability? It was L, right? It was L. So what was that? It was dl by dl by d phi. dl by d phi will be less than 0, that is stable. Also you can write d cl by d phi less than 0, or also dcl by d beta less than 0. These are the stable. Okay. Directional stability, what is the yawing moment? N. So dou n by dou psi less than 0 or dou n by dou beta greater than 0. This is what is in terms of coefficient dou cn by dou psi or dou cn by dou beta table. Okay, this one is clear, no issue. But in examination, sometimes they are using this type of terminology. This Cm, Pcm by d alpha, they are writing Cm alpha. Okay. Similarly, this dcl by d phi, they are writing cl phi, or they are writing cl beta. They are writing cl beta. If they are writing cl beta, it means dou cl by dou beta or dcl by d beta. That's the meaning. So dcl by d or this one. And similarly here it is Cn psi less than 0 or Cn beta greater. So you must aware with this short code also. Cm alpha must be less than 0. There should not be a confusion. If in exam Cm alpha they ask Cm alpha greater than 0, Cm alpha less than 0, Cm alpha equal to 0. But if you don't know meaning of Cm alpha, then you will not able to. Cm alpha means dCm by d alpha, okay, or dou Cm by dou alpha. Hmm? Similarly, Cl phi means dCl by d phi or dou Cl by d phi. Cl beta means dCl by d beta or dou Cl by dou beta. Simple. Cn psi means dou Cn by dou psi or dCn by d psi. Cn beta means dou Cn by dou beta or uh, dou Cn by dou beta or dCn by d beta. Meaning is same. So this short code also you should know. Always remember all the moment. Here in practice we had written for the longitudinal static stability because we had solved the problem. So we had seen that pitching moment we had taken about CG. Similarly, our all lateral stability, directional stability, we have to talk about the CG. Okay, always remember because stability we have to check about the CG only. Okay, so this is done.